In this lesson, we're going to look at why interfaces are so important and why we should always be passing stuff to our function blocks and functions via interfaces. Now, before we jump in and I sort of say to always use interfaces, there are times where interfaces aren't appropriate and that we should be calling for information directly from a function block. So things like the mapping layers here. Well, we don't want loads of inputs and in-outs and interface elements on our input mapping layer because the input mapping layer is always going to be bespoke to the project we're working on, because it depends on our hardware setup, it depends on our wiring and our panels, so it doesn't make much sense to pass that information through the interface when we can write it directly in the function block and use it as a container, which is what it's being used for. And with that being said, that should mean that you only ever have one layer deep of function blocks that access global data. So for those that might not understand what I'm talking about, global data or accessing global data would be accessing something like the M register flags, so M 3.0, for example, or accessing something like the input registers or input tags, so I 1.0, for example, or things such as global data blocks. So if we were to look at our data blocks here and go to asset data blocks, valves, so all of these are globally accessible blocks. You can access them anywhere in a function block or a function or an OB. You can always reference them. And we could work with the data directly that way, which means that we don't have a pointer. It means that we don't have an interface. We don't have anything. We're just working with it directly. And especially people who come from a Rockwell background might be inclined to program like that, but it doesn't fit the paradigm that we're putting together here. The pattern of programming that we're putting together for asset-orientated design doesn't work because we want to be able to reuse things. So you can break that paradigm really, really easily. So if I was to open this global access example, remember, the intention of this is to set set alarms based on their index in an array. So we will want to reuse this block. Now, here I have added a global alarm inhibit. So as long as the global alarm inhibit is off, then we're free to set our alarm. And on face value, that's fine. There's nothing wrong with that. Every single global access example or every single instance of this block will be able to access M3. That's fine. And there isn't anything wrong with that in this particular project because we know that M3 is available. We know that that global alarm inhibit is available. Now, just say that we want to use this on a different project where M3 is already assigned to something else. So this is a standard block. You now have it in your library and you're dropping it into another project, and M3 is already declared as something else. Well, now you've got a problem because you're going to have to reversion this just because M3 was used. When in fact it would make a lot more sense if you were to add to the input interface and put on here a global alarm inhibit. And instead of accessing the data directly, we accessed it through the interface. So if I go back to the other block that's calling it now and just update the block call, the reason why this is a better approach is because now in the case of the other controller that already was using M3 for something else, it doesn't matter. We can reassign it to M4, for example, and that would be fine. We can have a lot more flexibility because we're using an interface. And if the project doesn't require a global alarm inhibit at all, you can simply put the constant false on there. And that way it will never be inhibited. So there are reasons for using interfaces, and the more that you do it and the more that you work with them, the more you'll realize that it's beneficial to follow that sort of design pattern that gives you that flexibility of deciding, I'm going to fix a constant here, I'm going to pass this variable in, or you get the choice to stick on the front of here whatever it is that you need to do. For example, you might have multiple logic that makes up whether or not you're going to do a global alarm inhibit for a particular project. But the standardization of this block has not changed. But what you're doing around this block changes the behavior of this block. And that's important for later when we start talking about bespoke functionality for individual assets. And we'll come on to that in more detail, but it builds from this idea that by using interfaces, we can extend functionality before and after our block based on what we pass in and out of our interface. And before we end the lesson, there's another reason as well. If I just jump in and change this back to what it was before, so stick that back as M3, update this one back to what it was, and then just remove that. You'll also find that if you are adding your standard blocks that you've created into your library, so if I try and put this global access example into my type library, so I'll drag that in because I want to create a new library type, we will get a warning saying this block contains access to PLC tags. So the object global access example contains access to PLC tags. We do not recommend that you release this type. If you do release this type, it will no longer be possible to provide the object with know-how protection. It doesn't do a very good job of explaining why, but the reason is what I said earlier, that it is relying upon a PLC tag or a global data block that you cannot guarantee is there in another project. So if you're going to go and put this in a library, in a project library, I know it's a project library that's relative to this project only, but there's nothing stopping anybody from moving it from a project library into a global library. And if it gets moved into a global library, it could then be put on a different PLC, and you could end up with unintended consequences of accessing tags that were not designed to be accessed by this block because of how another PLC is configured. So it is important to understand what you're doing when you start accessing global data from within reusable blocks. It's not as simple as just saying, well, I know that will be there, so it's okay. It's okay if this is a one-off project and it's very, very clear that you're not going to reuse anything, even if the block is reused multiple times inside that one project. I would still have reservations about doing it, but it's worth taking the extra time to ensure that you are not accessing anything via the internals of a function block that's reusable. And just touching on what we went through in our previous lesson with copying data through like input and output interfaces, this is another great example of why using in-out is beneficial, because if you were nesting function blocks inside each other and copying that data so you didn't have to access global data directly, you're making multiple copies of that structure that you're passing through just to try and facilitate the fact that you're not accessing global data directly. And you can make your projects massive very, very quickly by copying data all the time. So going through a pointer, going through an in-out interface, that's the best way to reduce the sort of copying, accessing the data directly, and updating your interfaces so that you're not accessing global data keeps the library status intact. You can copy stuff to the library without it being a problem, and it also guarantees that you can use that block somewhere else and not have to worry about the integrity of the project that you're moving this object to, because it's all self-contained, wrapped up in an interface, and the logic is inside the block. And that is the principle. These two lessons that we've just been through make up the core principle of this approach. Like, you have to use the interface and you have to make sure that you're using references. So again, any questions on this section, drop me a message on LinkedIn or in the comments, and I will do my best to help you understand anything that you're stuck with.